Okay, so today we're going to learn the quotient rule. And quotient is another word for division. Now we did some division with the basic rules, but it was all division that you could turn into a power rule. Or you could pull it apart because you were dividing by one term and clean it up and turn it into a power rule. So this is division that you cannot simplify. So when you have division, you cannot do a power rule on the top and a power rule on the bottom. It doesn't work that way. So to take the derivative of a rational function, so f is the top and g is the bottom, and this just says, hey, we're taking the derivative of it. All right, so here's what you got. You're going to leave g alone. Tell you what, let's color code this a little bit. Let's let f be the top. Okay. So you're going to leave g alone, and then you're doing the derivative of the top minus, now remember when you did the product rule, it was leave it, derivative, plus derivative, leave it, and I said there's a plus sign in here, so technically it doesn't matter if you leave it and then do derivative or if you derivative and then leave it. It doesn't matter because both terms are going to be positive. This formula, however, has a minus in it, so it matters. So it's the bottom times the derivative of the top times, or minus, the top times the derivative of the bottom over the bottom squared. And then this just says, hey, the bottom can't equal 0. Okay, so yeah, this is a tough one to remember. So there's this stupid little song that almost every calculus student and teacher learns. It's something I learned and it's helped me tremendously. Okay, so we're going to call the top high and the bottom low for obvious reasons. Okay, so here we go. Low, then the derivative of the high. So we're going to say low d high, d for derivative, derivative of the high, minus high d low, because derivative of the low, over low, low. All right, ready? Low d high minus high d low over low, low. Low d high minus high d low over low, low. So when you're doing the quotient rule, just remember that song starts with low. Low d high minus high d low over low, low. Low d high minus high d low over low, low. You need to say that over and over and over. And every time you do a problem, that needs to come into your brain. Low d high minus high d low over low, low. I promise it will help. Okay. So y prime equals, this is high, this is low. So here we go. Low, d high, so derivative of the high. That's just power rule. Minus high, d low, over low, low. And now I clean. So y prime equals 5x squared plus 5. Watch the minus. Minus 10x squared plus 4x. Negative 5x squared plus 4x plus 5. Very rarely do you need to write the bottom twice and lobster it out. Usually you're going to leave the bottom in its parts and potentially try to cancel with something on the top. This one doesn't work because it doesn't factor. One thing that they could have done for the top, because there's a negative in the front, if they wanted to and it was multiple choice, they could have taken the negative out. So be prepared to see something like that, multiple choice answers. Low D high minus high D low over low low. Okay. Let's see. This has 3 different levels. I'm going to clean this up. I'm going to do some prep work on this. So I'm going to put the 3 over 1, and I'm going to multiply by x over x. So no calculus yet. That's going to give me 3x minus 1 over x plus 5, which is over 1. And I'm going to Bojangles. 3x minus 1 over x times x plus 5. Okay. So now I'm ready to go quotient rule, but hold on just a second. If you go quotient rule with this as is, think about this. When you do the derivative of the bottom, that's now a product rule. So you'll have a product rule within your quotient rule. And if I can avoid that, I want to. There are some times you can't avoid that. But for this one, I can, just by distributing that x on the bottom. And again, remember, on the last video, I talked about how these problems are won and lost in the prep. Okay? So now it's just a very simple quotient rule. Okay? So here I go. Y prime, low, D high, minus high, D low, over low, low. Let's see. Sometimes I'm going to look here and say, okay, that's a term and that's a term, and let me see if they all have something in common, and see if I can GCF it out. And they don't have anything in common, so I'm going to distribute. Let's see, 6x squared plus 15x minus 2x minus 5. And now I'm going to run my negative through. Now we're getting into some of the really fun, air quotes, nitty-gritty of derivatives, the algebra. You don't want to miss a quotient rule problem because you lobstered wrong or because you forgot to run your negative through. So when you take your test on this and we look at the ones you missed, we're going to categorize them. Was it a calculus mistake or was it an algebra mistake? You don't want to be getting problems wrong in calculus from your algebra. So slow down, think through everything, especially on the algebra front. Y prime, negative 3x squared plus 2x plus 5. And again, on this one, there's a negative in the front, so if they wanted to, they could take a negative out if they wanted to, but they don't have to. Obviously, they could not have both answers because they're both correct. Okay, now, some people get to this problem and they'll say, okay, it's quotient rule. Let me go low D high. But remember, when you're dividing by one term, if you will pull it apart and simplify each term, then you can just do a power rule, which is so much easier. So instead of going low D high, I'm going to pull it apart. So I'm going to algebra first. So all I did was pull it apart, and I reduced. Now when I go y prime, pull the 2 down, I'm doing power rule. So 2 6, so 1/3 x plus 1/2. There you go. Okay, now watch. I'm just going to run through this with quotient rule so you can see it. So just watch. Low d high minus high. Now derivative of the low is going to be a 0 because the derivative constant is a 0 over low low. Well, that 0 wipes all that out. So that would be 12x plus 18 over 36, which reduces to 1/3 x plus 1/2 if I pull it apart. So much easier to separate it. So when you divide by one term, separate it, clean it up, and then do the power rule. Okay, same thing here. So the prep work is going to be to distribute the -3 on the top and then to pull it apart and divide them both by 7x individually instead of going quotient rule. So prep work, y equals -9x plus 6x squared over 7x. Still prep work, -9/7, x's cancel, plus 6 over 7 with an x left. Y prime equals, well, the derivative of a constant is 0, and the derivative of 6/7 x is 6/7. Now I could show you quotient rule on this problem, but I'm looking at my work, and I would just love for you to trust me and know that it took 1, 2, 3 very big lines of work and then 2 lines of cleaning it up. So just trust me. When you're dividing by one term, pull apart, clean it up, do the power rule. Okay, number 5. Again, I'm going to clean this up. If I don't clean this up, then guys, what you have here is you have a product rule with a quotient rule in it. And I don't want to do that. So I'm going to clean. First, I'm going to distribute my x through. Then I'm going to get a common denominator. I think. Yeah, I'm going to get a common denominator. There we go. Now I'm going to go derivative. Now I cannot pull this one apart and clean it up. This is a quotient rule all the way through. So low d high minus high d low over low low. Okay, algebra. Lobster -6 minus 8. Run the negative through. Good notation. Does the top factor? Because if it factors and one of those factors is an x minus 4, then I need to do that because that's going to cancel. 24. 4 and 6, 3 and 8, 2 and 12. None of that's going to give me an 8, so no. But I have to check. Okay, number 6. Only 3 more to go. There's a single term on top. Unfortunately, that does not help me. I cannot pull it apart. But I do have a power issue on the bottom, so I'm going to rewrite this or prep it and write 3x to the 1/2. Okay, now here I go. Low, D high, minus high, D low. Pull the power down. Subtract 1, which would be 2 over 2, so negative 1/2. Derivative of 2 is 0 over low, low. Okay, now I'm going to clean. Good notation. Let's distribute here. When you multiply, you add your powers. So that's 1, 2 over 2 plus 1 over 2 would be 3 over 2. Okay, minus, when I multiply, I add my powers. So 4 over 2 plus a negative 1/2, 3 over 2. Oh yeah, this one's fun at the end. Okay, these are like terms. So if I go common denominator, that's a 12 over 2. 12 over 2 minus 3 over 2 is 9 over 2. So 9 over 2 x to the 3/2 plus 4x over 3x 1/2 plus 2 squared. Okay, now watch what I'm about to do. They will never leave a fraction like that. Okay, so your next step would be a common denominator for the top and then put the bottom over 1 and then Bojangles and all that stuff. I'm going to show you a trick and it will always work. When you have that little fraction, that 9 over 2, if you will just take every term and multiply it by 2, so I'm going to multiply him by 2 and him by 2 and him by 2, every term. Okay, well these twos cancel. And so that gives me 9x to the 3 over 2 plus 8x over 2 times 3 to the 1/2 plus 2 squared. Everybody got a 2. They will never have what's in purple. They'll have that. All right, number 7. So I'm dividing by one term, so I get kind of excited, but if I can't simplify it at all, like it's a trig over a non-trig. Now I could do this because they're both single. Not y prime. Y equals, I could write it as x to the negative 1 cosine of x and use the product rule. The leave it derivative plus derivative leave it. I could do that. I can also do the quotient rule. I'm gonna do the quotient rule. Low, D high, minus high, D low, over low, low. Oh, I lost an x. Nope. Let's try that again. They could take a negative 1 out if they wanted to. Either way would be fine. Okay, I'm going to go product rule. And please don't sit there and think, well, if I can do the quotient rule, that's fine. I don't need to watch the product rule. Well, there may come a time where you need to do the product rule on a problem like this. So just watch. Leave it, derivative, plus derivative, leave it. Multiply him by x over x. There he is. Okay. Last one. I can leave it alone and do quotient rule. If you pull this apart, cosine over sine is cotangent. You could do that. I can take the derivative of this, that's easy, but this, that's still a quotient rule. You still have to low d high that thing. You can't just take the derivative of sine and leave it on the bottom. It doesn't work that way. The derivative of 1 over sine is not 1 over the derivative of sine. Ooh, I'm going to say that again. The derivative of 1 over sine is not 1 over the derivative of sine. You can't isolate the denominator and just pull the trigger on the derivative in a denominator randomly. You don't get to do that. So, if I did it the way that I've pulled it apart, I would do quotient rule and then derivative of cotangent. I think I'm going to hold off and go back to the original problem and do a full-on quotient rule. So y prime, low, d high. Okay, d of the 1 is 0. Derivative of cosine is a negative sign, but it's already negative, so positive sign, minus high, d low, over low, low. Remember, put your square on your sine and not your x. I'm going to distribute my cosine and that negative. Ooh, you know what I see? I spy with my little eye a Pythagorean. Looky there. So y prime equals 1 minus cosine x over sine squared x. Ooh. Sine squared x. Let's think a little second. Hold on. Sine squared plus cosine squared equals 1. So sine squared equals 1 minus cosine squared. And if I factor that, then one of those would cancel. Oh, looky here. Y prime equals 1 minus cosine x. I'm going to replace sine squared with a 1 minus cosine squared, but I'm going to factor it because one of those factors is going to cancel with the top. Heck yeah. So my answer could be, so they could have that or they could have that. It's their choice how far they want to take it. That's why you've got to be 100% sure about your algebra and your trig, so that when you're done and you go try to find your answer multiple choice and you don't see it, then you know there's something else. So you got to reach into that tool belt and pull out some other trick. Very nice. That's a good problem. Okay, so as you guys can see, at this point, those derivatives, the power rules, and the derivative of the trig need to be like right there, second nature, so that when you're doing this quotient rule or the product rule, the derivative of the individual terms is easy. So make sure you're solid on those.